Hello everyone, we will continue with the DC machine examples. The first example examines the shunt DC motor with the specifications of 224 volt terminal voltage, 25 kilowatt of output power, 1000 RPM and 0.86 will be the efficiency during the rated load. Also, armature resistance and the field current are given. So let's start with the input power calculation. For the input power, we will use the output power over efficiency expression, or for the input power, Vt times IL can be used, but we don't have enough information for the IL. So for the output power, it is given as 25,000 divided by 0.86, which is the efficiency of this machine. So 29 kilowatts will be the input power of the machine. Then let's continue with the load torque calculation. For the load torque, it is related with the output part of the motor. So output power divided by the angular velocity, motor speed will be. So 25,000 will be the output power divided by Wm, which is 1000 in revolution per minute, and we will convert to radian per second for the Wm. And the answer will be 238.8 Newton meter. After that, let's continue with the total resistance to limit the starting current 1.5 times the load current. So, because of this, we should start with the load current, line current calculation. So, IL can be calculated with the input power divided by Vt. And as we calculated, input power is 29,000 and the terminal voltage is 224. So from here, it can be calculated as 129.5 amperes, but we need to use 1.5 times higher value. So 1.5 IL will be 194 ampere. And we have a shunt excited DC motor. So if we remember the equivalent circuit of the shunt DC motor, EA and RA will be the armature circuit components, and in the field side we have RF, LF. So here IL will enter and will be divided into two parts as IA and IF. So to calculate the armature related parameter, because we will insert a resistance to limit the current in the armature side, we should find the IA. For IA, if we check the node, we can use IL minus IF expression, and we will use this current as IL. IF is given as 1.8. So from here, 192.2 amperes will be our starting limited current. So from here, from the circuit, let's calculate our external, how much resistance we will add to RA. Let's try to calculate. The total resistance will be equal to Vt over IA. Why? Because during the start, the induced voltage, generated voltage EA must be equal to 0. So the remaining expression will be Vt over IA during the starting phase. So from here, we have 224 volt, and according to our calculation, the current will be 192.2. So 1.16 ohms will be the total resistance. If you want to clarify what is the external in the circuit, how much external resistance you need, you can subtract RA, and the external resistance will be 0.92 ohms. In the second one, we have a shunt excited DC generator. For this case, we will clarify some currents and induced voltage of the circuit. So let's start according to given values. Let's start off with the calculation of IF. Again, we have a shunt excited DC machine. In the shunt excitation, for the field current calculation, we must use VT because it will be parallel connected with the field circuit also. So the voltage divided by the resistance, 250 according to given values and 50 ohms, will be 5 amperes. In part B, we can calculate IA, and because of the generator operation, if we check the circuit again, this current and the IL will be reversed. So that means for IA calculation, IF and IL must be added. So IF and IL. IF we have calculated as 5 and IL is given as 195. So 200 amperes we have on the armature side. Then let's calculate the internal generated voltage of EA. We have a generator operation, so EA must be the main supply. That means the terminal voltage and the voltage drop on the armature resistance will give us the EA value. So 250 is the terminal voltage, RA 0.05 ohms, and according to our current calculation of armature current, which is 200, so we have 260 volts. For the last part, let's calculate the load resistance. So we have a generator operation and how much resistance we have according to given condition. So the terminal voltage and the line current, load current division ratio 250 divided by 195 will be 1.28 ohms. So the load resistance can be calculated according to this expression. Okay, thank you for watching.